The speed of light is one of the most fundamental and important values in the whole of science. It defines the fastest speed that anything in the universe can travel, and it's even used in Einstein's equation E=mc². With such an important value, it makes you think, I wonder if we could calculate the value of it using a bar of chocolate. So what we need for this experiment is a simple bar of chocolate, the bigger the better, a ruler and a microwave. Now the first thing you need to do is take any rotating mechanisms out of your microwave. So this is normally just the plate at the bottom, but if you need adult supervision, make sure you get it. But all you need to probably do is just take the plate out the bottom, because we don't want the microwave plate to be spinning around. You can then put your bar of chocolate into the microwave, and this normally takes between 10 seconds and a couple of minutes. We'll put it in for about 10 to 20 second intervals and just keep checking it. You want to catch it before it fully melts, but it just begins to start going soft. So while that's in the microwave, let's try and think what's actually going on. So light can be thought of as a wave travelling through space. And the wave is just like a wave on the ocean. A wave on the ocean and light both have peaks and troughs, and you can measure the height of the peak. They also travel at a certain speed, and there's a certain wavelength. That's the distance between any two similar parts of the wave. i.e. you measure the distance between two peaks or two troughs, and that's the wavelength of the wave. But when we talk about light, we're not just talking about light you can see with your eyes. There's a whole spectrum of light that's invisible to the naked eye. This goes from gamma ray, X-ray, ultraviolet, the optical light that we see, infrared, microwave and radio. And all of these properties have the same speed, the speed of light. So all light waves have the same speed, the speed of light. But you can also define them by their frequency and their wavelength. There's a nice easy equation that links these three values together. And that says that the speed of light is equal to the frequency of the wave times its wavelength. But what's this got to do with our bar of chocolate in the microwave? Well, light waves, like ocean waves, have peaks and troughs. And it's the points where the peaks of the light touch the food that it gets cooked the most. This is why your microwave normally spins around, so that all the points in the food get under a peak at some point and your food cooks equally. But if we take the rotating plate out, it means that some points in the food will be cooked more than others. With our bar of chocolate, this means that some points of the bar of chocolate will be melted more than others. Now, if we measure the distance between any two melted points on the chocolate bar, we're measuring the distance between the two peaks, which is the same as measuring the wavelength. So, we can now measure the wavelength of the light. So now we need the value of the frequency of the microwave. Now, sadly, we can't measure this, but you can find it on the label on the back of your microwave or in the instruction manual, hopefully. Now, the value for the frequency for my microwave is 2450 MHz. Now, we need the value in Hz, which is Hertz. The M stands for mega, or also for million. So what this means is that our value for my microwave is 2450 million Hertz. So if the frequency in the back of your microwave says MHz, just multiply it by 1 million. So 2450 megahertz becomes 2450 million hertz. You then need to measure the distance between two melted points on the bar of chocolate. Now you might be able to see this, but if not, you can get a fork or a spoon and just touch lightly on the chocolate to see which parts are melted more. So now we can calculate the value of the speed of light. We have the frequency, hopefully from the back of your microwave, and we also have the wavelength, which we calculated from the bar of chocolate. Now, all we have to do is multiply these two values together, but we need to make sure the units are in hertz and in meters. So in hertz, the frequency of my microwave was 2450 million hertz, and the wavelength was 10 centimeters, which is 0.1 meters. So we need to multiply these two values together, and I find that for me, the speed of light that I calculated was 245 million meters per second. But now we need to compare this to what the actual speed of light is. Well, the actual accepted value is around 300 million meters per second. So I wasn't particularly far off. 300 million meters per second, 245 million meters per second is very close. It's not quite there, but then I was calculating using a bar of chocolate, so it's not that bad. So that's how you can use a bar of chocolate to calculate the speed of light. Now my value is pretty close, but I'm sure some of you got even better values, so why not send me a picture or leave a comment on this video telling me what values you got. Thank you very much for watching. Don't forget to like, subscribe and check out the rest of my videos, and I'll see you guys soon.